So let's talk about the AI you use every day. Is it an actual genius full of facts? Or is it more of a confident gambler, just really, really good at guessing? Well, a new paper from Artificial Analysis digs into this exact question, and we're going to break it all down. I mean, we've all been there, right? You ask an AI what you think is a simple, straightforward question, and it comes back with an answer that sounds super confident, totally plausible, and is just completely wrong. It doesn't say I'm not sure, it just makes stuff up. This whole hallucination thing is a huge roadblock for AI. So what's going on here? Why does this keep happening? Okay, let's look at a perfect example right from the research. Someone asks about MCP in the context of software. Now look at the model on the left. It just confidently spits out multi-client persistence, which is wrong, totally wrong. But the model on the right, it gets it right. Model context protocol. See the difference? One of these answers is genuinely helpful and the other one sends you down a complete dead end. This is the problem in a nutshell. So the researchers have a great name for this. They call it the confident charlatan problem. And it turns out a huge part of the issue might just be how we're testing these AIs in the first place. Think about it. Most tests give you points for a right answer. And that's it. Nothing happens if you're wrong. So what does that do? It actually encourages the AI to guess. There's no penalty for being wrong, so why not take a shot? It's a system that basically rewards being a confident liar. Okay, so to fix this, the folks at Artificial Analysis came up with a whole new way to test these things. It's a new benchmark with a really clever scoring system, and it's designed to figure out how reliable an AI actually is. They call it the Omniscience Index. Okay, here's how it works. It starts off simple enough. If the model gets an answer right, boom, +1 point. That's the baseline, right? Just like any other test, you're rewarded for being correct.
But here, this is where it gets really interesting. If a model hallucinates, if it just makes up a wrong answer, it gets -1. That one little change completely flips the script. All of a sudden, just guessing becomes a super high-stakes game. There's a real cost to being that confident charlatan.
And here's the final piece of the puzzle, and it's absolutely crucial. What if the model knows it doesn't know? Well, if it just says, I don't know, it gets 0 points. Not +1, not -1, 0. This basically creates a safe zone for honesty. The AI isn't punished for admitting it doesn't know something, which means it has a good reason to just stay quiet instead of making things up. So when you put it all together, the Omniscience Index isn't just measuring what an AI knows. It's measuring if an AI knows what it doesn't know. The final score is just the total of all those points over thousands of questions. And the meaning is simple. A positive score means the model is right more often than it's wrong. A negative score? Well, that means you're probably better off not even asking it in the first place. All right, so the researchers took this new test and threw it at 36 of the world's top AI models. We're talking 6,000 really tough fact-based questions in specialized fields like law, health, and software engineering. And the results, well, let's just say they were not what anyone expected. They were pretty shocking, actually. Okay, just take a look at this leaderboard. The first thing you notice, all that red. Almost every single model scored below 0. Let that sink in. That means they were wrong more often than they were right when they actually tried to answer. This just shows you how widespread this hallucination problem really is. Yeah, let's just hammer this point home for a second. Out of 36 of the most advanced models out there, only 3 of them scored above 0. Just 3. The rest, the vast majority of these incredibly powerful AIs, are basically just unreliable gamblers when it comes to facts. The researchers themselves put it a bit more formally, of course. They said, the results show, and I'm quoting here, persistent factuality and calibration weaknesses across frontier models. In other words, it's a huge, blinking sign that the entire AI industry has a massive reliability problem on its hands. But the story doesn't end with that shocking leaderboard. When you dig deeper into the data, you start to see these distinct personalities emerge among the AIs. It's fascinating. Okay, check out this chart. It maps every model based on 2 things. Going up and down, you've got traditional accuracy, how often it's right when it answers. And going left to right, you have the Omniscience Index, basically its reliability. That top right corner, that's the sweet spot. That's where you want to be. And this chart gives us these 4 really clear AI personalities. Up in that top right corner, you have the reliable experts. Think Cloud 4.1 Opus. They're smart and they know what they don't know. Then you have the cautious students, like Cloud 4.5 Haiku. They might not know as much, but they're smart enough to keep quiet when they're not sure, probably tuned for safety. Over on the other side, you get the gamblers. The confident gamblers like GPT-5 Minimal know a lot, but boy, do they guess a lot too. And finally, you've got the chronic guessers. They're wrong a lot, and they don't have a clue. So this brings up a really important question. Doesn't being smarter just mean you're also more reliable? Well, you'd think so, but the data says, nope, not at all. This chart plots that reliability score against a standard measure of general AI intelligence. And look at it, the dots are all over the place. There's no clear connection. You can have a genius-level AI that's also a terrible liar. So, what's the biggest takeaway here? It's this. Overall intelligence does not predict factual reliability. They are two different things. An AI can be amazing at reasoning or writing code or creative tasks and still be a completely untrustworthy source for simple facts. The smartest model is definitely not always the one you can trust. And it gets even more detailed than that. Check out this heat map. What this shows us is that no single AI is the best at everything. Not even close. The green spots are where a model really shines, and the red spots are where it's weak. And you can see even the top models have big patches of red. Everyone has subjects they struggle with. I mean, this really drives the point home, right? The best model for legal questions is Claude 4.1 Opus. But for business, it's GPT 5.1. And for health, it's Grok. Just like with people, expertise is specialized. There's no one-size-fits-all genius. Okay, so what does this all mean for you, for us, when we're trying to pick the right AI for a job? Well, this research gives us a much, much smarter way to think about it. It really comes down to 3 steps. First, know what you're doing. Are you looking for creative brainstorming, or are you looking for hard facts? Because those might be 2 different AIs. Second, you've got to look past the hype and the main leaderboards. The best model overall might be terrible at the specific thing you need, like a legal question. And third, test it yourself. Give it a curveball. Ask it something you're pretty sure it doesn't know, and just see what it does. Does it make something up, or does it admit it's stumped? And really, all of this research leaves us with a really big question to think about. As these tools get woven deeper and deeper into our daily lives, what do we actually value more? Do we want raw, flashy intelligence, even if it comes with the risk of being misled? Or do we want earned trust, the kind of reliability that comes from an AI knowing its own limits? This new way of looking at AI, it might just be the key to helping us make that choice.